Hey guys, welcome. I'm Sanjeev Javia, CEO of PRōZE Performance Nutrition. I'm super excited to have you guys here today. We're going to talk about something that is really relevant right now. There's a lot of conversations going on, a lot of discussions, a lot of misinterpretations or misrepresentation of information, and that's why we kind of wanted to have this. And so before we get jumping on this real quick, I just want to say, one of the big reasons why we started PRōZE was not only to develop amazing products, but we wanted to be a platform of education. We wanted to be able to give all of you education in nutrition and health and wellness that really empowered you so you could make huge actions for yourself. And I think right now more than ever, this is so important. Like, one thing that I've learned during this whole process is like health educators like us, we need to be accountable, right? We need to be out there giving all of you the right information because it truly is a public service. It's something that we've been learning, experiencing, educating on. So it's a real honor to be able to give you guys this information, give you things that you can really understand and take a hold of, and then most importantly, help others with. So please take this information and just don't hold it with yourself. Share it with your friends, share it with your family, share it with your neighbors, because really at the very end of the day, we're going to get through this because we are together, we're all doing our part, and we're all making sure that we're looking after each other, right?
That's the important part.
Yeah.
Exactly right.
So here's the deal, guys. Like I said, what we want to do is we want to maybe calm some of this panic that's going on, to bring some enlightenment or some understanding to some of the uncertainty that's out there, or comfort to some uncertainty out there, and then most importantly, to get some information that dispels some of these misrepresentations or mistruths that are out there. So we're actually going to talk about a few different things today. So number one, we're going to understand the coronavirus, understand COVID-19. We're going to understand how it really affects the body, what it does to the body, and then what we can actually do about it, and what's fact and fiction, and then we're going to take some of your questions. So this is going to be a really great thing for all of you, and I'm obviously excited to have one of our board members, Dr. Dave Vigerust, here with us today, or I didn't screw that up, okay, right? And so Dr. Vigerust, it's an absolute honor to have you here. Can you tell us a little bit about yourself? And
it's great to be here with you too. I've had, for probably the majority of my adult life and probably my teenage years, an ultimate fascination with viruses. So, despite this being a really trying time, this is also a really interesting time for those of us who are scientists and biologists trying to understand something new coming into the human population. It's not the first time. It obviously won't be the last time, but there's an enormous amount that we can learn from this for the next time so that we're more prepared as time goes on and potential exposures come again. So for viruses, this is kind of a pet interest of mine, an interest of mine that I've had throughout the majority of my training. I've done this for 25 years.
You have a doctorate in infectious disease?
A master's in microimmunology, a doctorate in pathology, actually.
Okay.
But the majority of that was around viruses, HIV, influenza virus, respiratory viruses. I spent some time at St. Jude Children's Hospital, which most of us know is a cancer institution. Very few of us know that it also has a very substantial virology and immunology department that studies a variety of different types of viruses, in particular influenza.
Oh, wow.
So St. Jude has always been, the last 30 or 40 years, one of the centers for the WHO in terms of understanding the ecology and what happens when these viruses get from the animal kingdom into the humans.
Sure.
We've had people there who are constantly sampling animals, birds,
wow,
all kinds of organisms around the world to try to understand how they move from an animal into us.
Okay.
And then I did a second fellowship at Vanderbilt in pediatric infectious disease, following on viruses like influenza, metapneumovirus, respiratory syncytial virus, rhinoviruses, all those kinds of things that we see on a seasonal basis that we're always bothered by.
Yeah.
But not to this same degree.
Yeah, I was watching one of your TED Talks, obviously, and they were saying, how much experience and education, obviously, and research that you've done in infectious disease, in immunology, in understanding how this actually reacts to the body. I mean, some of that work at St. Jude's, I mean, that was specifically on influenza and the flu, right? And
in influenza, and then also what happens often with patients who have an influenza infection is they get a secondary bacterial infection that leads to pneumonia. So what most of us don't understand, you see sometimes, well, somebody died of the flu.
Yeah.
They didn't necessarily die of the flu. They died of consequences related to the flu.
Yes.
So something happened to their body, their lung architecture. After that flu cleared, something else came in and took advantage of that space. And oftentimes that is a bacteria.
Gotcha. Okay, so great. I'm glad that you started there. Is that, let's do this, okay, right? Let's take a step back and let's hit some fundamentals, okay, right? And so the first fundamental that I really want to have you explain to us a bit better is, what's the difference between a virus and a bacteria, and what is one more dangerous than the other? Explain that just a bit.
They can be, one or the other can be more dangerous than the other. They're not universally, bacteria is not universally worse than a virus. The biggest difference is bacteria are single-celled organisms that can survive on their own. They have all of the components to be self-sufficient.
Okay.
Viruses, on the other hand, are entirely dominant, are entirely dependent on the host.
Okay.
We're the host. Dog's a host. A cat's a host. Anything can be a host for a virus. Viruses are essentially inert. We oftentimes say, well, it wants to do this, or the virus lives here. Viruses are not alive from the technical standpoint. They're inert. They're combinations, little balls of protein and sugar and lipid and DNA or RNA.
Okay.
Right?
Okay.
They need us. They need a host in order to do whatever it is to
proliferate.
To replicate, to divide, to spread. But they can't do it independently. They need something else to move them forward in their biology.
Gotcha. So bacterias, they can just live by themselves, they can hang out by themselves, they can replicate by themselves.
Right.
It's just that a virus is actually needing another host or another cell to be able to do all of its damaging work.
Right.
Is that right?
Yeah, scientists oftentimes will call a virus an obligate parasite.
Okay.
Right. So it needs us in order to do whatever it needs to do. And in doing so, it takes advantage of all of our biology.
Okay, gotcha.
So in this case here, we're talking about a respiratory virus. That virus has to get into a lung cell or lung tissue. It then turns all of the normal process that lung cell does into producing more virus.
It basically takes over the entire mechanics of that cell and says, you're not going to do this anymore, you're just going to build more of me now.
Right.
Gotcha.
So it basically takes all the manufacturing ability of the cell and pares it down to the minimum that the cell can get away with without dying.
Okay.
And puts everything else into producing more virus.
Okay. And so we're going to talk more about why it's so important to understand that difference, because it is all about the host. Okay, right? And now you'll understand why, viruses that are sitting on counters and things like that are not inert. They're inert. They're just not doing anything. They can't do anything to you until they get into you. But okay, and so there's that. Okay, now let's do this. A lot of terms out there. 3 hot terms. You've got coronavirus,
right.
You've got SARS-CoV-2, and then you have COVID-19. What's the difference between these 3 words or terms? Are they the same thing? Define them, if you will.
So coronaviruses are a family of viruses. So there's a number of viruses that infect humans, dogs, cattle, beluga whales. I mean, you name it, there are animals that are infected by coronavirus. It's a family.
Now, are animals only affected by the coronavirus?
Yes.
Okay.
Yeah. So a whole family of different viruses. Those viruses are actually very old. Many of them, you can go back and you can look to see that they're 8,000, 9,000 years old. So we have a long history of these viruses interacting with the animal kingdom, us, whatever animal is out there. SARS-CoV-2 is the name of this particular virus, so it's a severe respiratory syndrome virus. It's the second one that we've discovered. SARS-1 back in 2003 was the first one. Okay. So it's almost related to the disease in a way. And then COVID-19 is this specific outbreak of this coronavirus in humans.
Okay, gotcha.
Right? So it's a family, a kind of class of virus, and then this disease itself we're going through right now, COVID-19.
So COVID-19 is the symptoms that are, is that that's the disease. The SARS-CoV-2 is the actual virus.
Name of the virus.
Name of the virus.
Corona is the family of viruses.
Exactly.
Right.
And so that's why when people keep talking about the fact that, hey, listen, this coronavirus is not new. It's not new. It's because it comes from a family of viruses that have been hanging around for tens of thousands of years.
Right.
It just so happens that this particular strain is different, which is the SARS-CoV-2, right? And then it's expressing symptoms that are unique to SARS-CoV-1 or whatever, and that's COVID-19.
Yeah, so this disease is COVID-19.
I just found out, by the way, I didn't know this, is that the 19 actually stood for 2019 because it was found in December 2019. Very interesting, okay, right? And so, okay, beautiful. So I hope that we got kind of the fundamentals down. So now here's the thing, guys, or Dr. Vigerust, okay, right? How did we get here? How did this happen? How did this virus arrive at our doorstep?
This virus comes from presumably bats, most likely bats. It has the closest genetic match with bat coronaviruses.
Okay.
And the likelihood is it moved from the bat in one way or another. It could be that humans and bats were in close proximity to each other. That's happened before, where these two animals don't normally meet and then all of a sudden they've met. It could have been that they come from a place where maybe the bat was a food source. It could be that the bat transmitted it to another animal that transmitted it to us.
That then we consumed.
That we consumed or we were in close proximity to.
Right, okay.
So we have so far, humans have had exposure to 7 coronaviruses.
Okay.
Right. 4 of those have been in the last 10 years.
Okay.
Right. So we're getting exposed to coronaviruses more frequently.
Okay.
That may be that we're interfering or entering into the normal habitat for wherever these viruses normally live.
Okay.
Now, since these viruses have been around for 8,000 years, they're not new, right?
Yes.
They've been around for a long time.
And these coronaviruses, by the way, they're in these animals, but they're not affecting these animals at all, right?
Quite often, these are just organisms that are living in this animal, and they're not causing any symptoms whatsoever. The animal doesn't have any ill effects from it. They're not sick. So if you looked at an animal, you wouldn't be able to tell that they had some illness. Okay. They're just going about their business.
Yeah, it's not affecting their immune system anyway.
Right. It's actually come to a balance in those animals, right? So in a bat, if this came from a bat, in fact, the bat probably does not have any ill effects whatsoever. It's not sick from this virus because they've come to adapt to each other. Mm-hmm. We right now are not adapted with this virus. So
we're not balanced with it.
We're not balanced with it, right? We haven't reached an equilibrium.
Okay.
Not to give the virus a human connotation, but the virus wants to survive. If it kills the host, no longer survives, right? Mm-hmm. So it has to come to some place where it's in equilibrium or in balance with the organism, whether it's a bat or chicken or whatever. Mm-hmm. If it doesn't do that, then the host dies and the reproduction of that virus is halted, right?
So are you saying that the virus actually it's okay if it coexists with its host, and the host, once it has this exposure and such, that there wouldn't be any symptoms?
Right,
okay.
Right. They've just come to live in balance, right?
Oh, gotcha. Okay. And so literally we could come into balance with this virus.
And we likely will if we're exposed to it for long enough. The 4 coronaviruses that we've been exposed to the longest was first discovered in the 60s. That's when we first knew that they were in us, right? Okay. Prior to that, we would get a cough, a cold, and it was just a nuisance, right? Okay. You had a couple days at home, you drank some hydration, you had some chicken soup, you got some rest, you got better, that was the end of it, right? Uh-huh. During that little phase of discomfort, the virus is actively reproducing and spreading to other people. That's why you cough and you sneeze. It's one way of getting it out to spread to a new host, right?
Yes, right.
Ideally, the virus wants to get into that host, do its business, get out of that host to another one, and not really harm the host, right?
So it gets, so like here we are, it's in this bat, somehow the bat then gets into some animal, whether it's directly us or another animal that we're exposed to, and now all of a sudden those virus particles get into our bodies, the human body, right?
And because we've never seen it before, we've never had prior exposure, number one, we have no previous immunity, so no way of fighting back from this virus.
It's unrecognized. We've never seen this thing before. It's completely foreign, so we don't have any shield or any type of fires.
Protection, exactly, except for what we're naturally born with, right? Which is what gets mobilized almost immediately is your body says, hey, this doesn't belong. I need to turn on these immune responses to make sure that I can get rid of it, right? Okay. But in a new host, the viruses oftentimes are left unchecked. So that means they start infecting all kinds of tissues.
Because the body doesn't even recognize it. Right. So it doesn't even recognize it as a pathogen because it hasn't necessarily seen it as a pathogen before. So it all of a sudden has this time in which it can start replicating. Is that right?
Right. It'll get recognized as a pathogen and potentially foreign.
Okay.
But your body is trying to work out, what do I do with this? I've not seen this before. I don't know how to handle this. And it's going to put out a lot of non-specific responses, right? Mm-hmm. We have two sides of our immune response. One of them is it just attacks anything that doesn't belong. The other side says, oh, I've seen you before. And because I've seen you before, I know how to handle you, right?
Okay, gotcha.
Right now, we don't have that.
Okay.
All we have is our innate, which is the one we're born with that says, I don't recognize you, you don't belong. I'm going to do what I can to get rid of you. But in the meantime, that virus is taking advantage of everything it can to replicate and to get out to the next host.
So here it is. It starts in this one area, or it starts in this one person, let's just say. Okay, right? Obviously, it starts in a person. Okay, right? But this son of a gun, started spreading like crazy. Mm-hmm. Okay, right? So how did this thing, again, arrive at our doorstep? Seemed fairly quickly.
Right. It probably came from, like I say, it came from an animal.
Yes. Yeah.
The advantage that this virus has in its propagation, and a disadvantage for us, is that it's able to spread from person to person.
Okay.
Some of the previous ones, it got in us. For those people who had the exposure, it made them sick, but it wasn't able to move easily from one human to another human.
Right? The transmission is a whole lot faster.
Yeah, there was some block, whatever that is.
Okay.
Maybe it went to a tissue that didn't have easy access. Maybe it didn't go into the lung, but it went into the liver, or went into the gut. Mm-hmm. It's not easy to transmit person to person from a gut organism, right?
Okay.
You'd have to be in contact with the feces, or so. It's a harder thing to do, right?
Okay.
But because we've got a respiratory virus, we've got a virus that's producing lots and lots of virus every time it goes through its replication cycle, and it's up here in the lung, and it causes us to cough, it causes us to sneeze, it causes us to do all these things, right? And there's a copious amount of virus every time we cough, every time we sneeze, even just breathing. Those small little microparticles of vapor are coated with virus. They're thick with virus.
So essentially, because you've got this cough, because you've got this sneeze, and it is a frequent cough and frequency, it has a lot of ability to get out there into the public, okay, right? As opposed to some of these other ones that maybe not, there wasn't as much quick transmission or opportunity for transmission.
Right.
Is that right?
So this is a unique circumstance in that most of the time when a virus or a pathogen comes from an animal source, it's adapted to that animal, number one. Number two, there are usually barriers to keep human to pig, human to chicken, human to, there's barriers, right? So it's something called tropism. The virus wants to be in a certain tissue, it wants to be in a certain animal. If it doesn't get those requirements, it doesn't do well. If it gets into an animal that maybe is a middle ground, right? So I'll give you a good example, the example of the 1918 Spanish flu.
Oh yeah, that's it.
Chickens are the normal host for influenza. And the virus ordinarily lives in their gut. It passages through their gut, it gets into the feces, another chicken picks it up, they get sick, not even sick, they get infected, they pass it before you know it, all of the chickens in the flock are infected, right?
Okay.
But because it's adapted for the chicken, it doesn't cause them much in the way of illness.
Right.
You have
it's in balance with the chicken.
It's in balance, right? So you have another animal on the farm, for example, you have a pig. The pig is not the natural host, but it's not too far away from the natural host. Mm-hmm. So it serves as what's called a mixing vessel, right? The pig has something that allows the virus to propagate. It also has something that maybe allows it to spread to something else. So what happened in 1918, the virus was in the chicken, then it bridged into the pig, and the pig was able to support it a little bit. The chicken and us are very far apart, right? receptors on the chicken are very different from our receptors. The pig has receptors that are similar to both, similar to ours and similar to the chickens. So it serves as a nice place for the virus to say, okay, I like this better, I like this a little bit, but I can transition to you even better.
And I've learned how to do that because there was a little bit of human, there was a little bit of chicken there,
right.
And so now
because I spent some time in this mixing vessel.
Yes.
And then once that got into humans in 1918, it's a brand new pathogen, never seen before. So it just goes to town and starts replicating, and it spreads very easily.
And is that the difference, by the way? And so like we talk about the Spanish flu, we talk about SARS, we talk about MERS. What makes this one so different than those?
Principally, its ability to transmit.
Okay.
Right. So SARS was perhaps not as easily transmitted. MERS probably not as easily transmitted. This one has the unique capability of spreading very easily.
Okay, gotcha.
And that's what we're worried about.
That's why
if it takes some time to start to spread, like MERS and SARS, did, you can contain it, right?
Yes.
People get sick, you can quarantine them, you can isolate them. They're not spreading it as fast. This has been such a rapid transmission,
yes,
that we haven't been able to get in front of it fast enough to stop it.
So not only is this something that is brand new to the body, okay, right? Never seen before, so we have no defenses, but number two, it can transmit so quickly and so quickly that's what's created the spread and the severity of issues with
right.
some individuals.
It's the speed at which it can spread.
Yeah, and so now here's the thing, okay, right? Is that we've got kind of to understand how does it actually, where is it affecting the body? Where is it? What cells is it affecting, and what's causing kind of the end result, which is
so its target is going to be the respiratory tree. So everything from the nose all the way down to the deeper parts of the lung.
Okay.
Ideally, it wants to get to the deeper part of the lung, right?
Okay.
So you get exposure into your throat and into your trachea, and the virus looks for its receptor.
Okay.
So it has, in order to get into our cells, it has to find a mechanism in, has to find a doorway in.
Okay.
That doorway is a receptor called ACE2.
The ACE receptor, okay.
Yeah, so it stands for I lost my train of thought.
Oh yeah, don't worry, I got it.
Angiotensin converting enzyme 2.
There you go. I'm not the doctor.
So this is an enzyme that's involved in regulation of our blood pressure, right?
Yeah.
So it's around, and it's in the lung, it's in the blood vessels. So the virus finds its receptor, attaches, gets brought inside the cell, and then once it's brought inside the cell, it opens up and spews out all of its genetic information.
So it needs that receptor, okay, right? And there are some people that are more predisposed to have that receptor or more of those receptors than others, right?
Right. We all have that receptor because it's important in regulation of our blood pressure. But people can have different quantities of this receptor, right?
Okay.
So there's different susceptibilities. Different kinds of conditions can drive that up. So sometimes if you have heart disease, obesity, you have diabetes, you have hypertension, that means your blood pressure is not being regulated, right? So that may mean that this enzyme has to kind of compensate.
Yes.
And if it compensates, there might be more expression in that particular patient. So more places for the virus to find entry.
See, so guys, that's why we talk about some of these other conditions that you are more susceptible to this disease. Like one, yes, you've got that trauma going on already in the body. Yes, you're already immune compromised. But the thing is you have more of these receptors that this virus is attaching to, which then allows it to proliferate at a greater speed.
Right. The other tricky thing about this virus is once it gets into the cell, ordinarily, it would go through its process of replication and then push itself out of the same cell. This virus also has the capability of doing what's called syncytia. So instead of exiting the cell and going off to another one, it goes sideways and it says, well, you're a good host for me over here and you're a good host for me over here. Rather than go out and come around, I'm just going to go sideways into you. So the two cells will blend, and when they blend, they start sharing. And now you get these giant cells. And these giant cells are all full of virus, right? So if that happens as it's going down your throat, the virus is exiting your tracheal tissue, it's exiting the lung tissue, it's looking at surrounding cells to get into, it's going sideways in the cells.
So that's why you get it all over.
That's why it starts, and gradually it starts to move down, and if it gets far enough down into the lungs, it starts to affect your ability to gas exchange. It affects your ability to take in oxygen and remove CO2, because those small little sacs at the very bottom of your lung are very, very, very tender, right?
Okay.
The lining is very thin in order to transmit gas back and forth. So you cause trauma to those little sacs. And when you cause trauma, your immune system says, I need to get in there and fix that. When it does that, it starts putting in fluid, and cells come in, and before you know it, the space that you have between for gas exchange gets thicker and thicker. It gets full of mucus, it gets full of material, gets full of fluid, and now that gas exchange doesn't occur very efficiently anymore. So now you need a ventilator, you need oxygen.
Now you got fluid
support,
buildup,
you got
right?
fluid.
Okay, you
Right.
can't breathe because there's no ability for
Right.
those gases to go back and forth.
Efficiently, right?
Okay,
so now you have to get, you're in the ICU and you're on a ventilator, you're on oxygen. The immune response is kicking in because you've got all of this virus that's being produced, and it's trying to control it. And the immune system starts spewing out cytokines. And these are proteins that the immune system uses to try to control in pathogens. That's bacteria, fungus, virus, it doesn't matter. But that whole thing is to make it an inhospitable environment for you.
Okay.
Bad thing about those things is they sometimes make your tissues leaky. They sometimes cause fever. They cause shock. So what you're getting is a cascade of things that are happening in response to the virus, trying to control it, and then the virus is causing damage to the cells, which causes a lack of ability to effectively move oxygen and CO2 back and forth. So now you're short of oxygen, you're short of breath.
You can't breathe.
You can't breathe. Your lungs are starting to fill up, and that kind of environment of trauma in the lung could lead to pneumonia. It could lead to bronchitis. It could lead to secondary infections. Bacteria can take advantage, and now populate in there also, because we're constantly breathing in all kinds of materials. So it's a cascade of problems that in some cases turns out to be very severe.
So this is why, when we start talking about who are the people that are most at risk, we're talking about individuals who are two things, it seems. Number one, that are immune compromised, because the immune system is not going to be able to effectively defend itself against it. And then secondly, if you're already having respiratory issues, right? Is that right? Though that's where, we talk about age groups and we talk about diseases, we talk about illnesses, but really what it is kind of the basis of those two things, right?
Right. So if you have underlying cardiovascular disease, if you have hypertension, if you have COPD, asthma perhaps. I don't know that there's been a whole lot of examination of asthma, but certainly if you're a smoker, if you vape, perhaps there's damage to the lung that makes it a little bit easier for the virus to take advantage and get ahead of your immune response.
Gotcha. Okay. And so here's what we're going to do now, guys. Hopefully what that gave you is a little bit of history about COVID-19 and told you a little bit about where it's really affecting your body, which it seems like the vast majority of where it's doing its damage is in our lungs, our respiratory mechanisms, if you will. And the problem with that, guys, is remember, if you can't breathe, you can't do two things. You can't bring health, providing oxygen into the body, and then you can also not get rid of toxicity, right? That's something that people are forgetting, is that if you don't have true proper lung capacity and the ability to get that CO2 and other toxins out, you're essentially living a life that is, you're very septic, if you will. You know what I mean, right? Okay, so now what we're going to do is let's go into some facts and fiction here, okay, right? So there's a lot of stuff that's going on out there. The number one thing that I kind of see is, okay, tell me about this heat thing. People are telling you, go into saunas. I had a friend send me some information about holding a blow dryer to my nose and breathing in that hot air. And the basis is okay, the virus doesn't like sunlight, it doesn't like heat, and it breaks down at 113 degrees Fahrenheit. Tell us a little bit about that.
So that's probably, in the narrow sense, that's probably true. The virus doesn't like heat in general. So if you had a virus on a tabletop and it was in the sunlight and it was hot, it's probably not going to survive very well. However, it has some protection when it gets into us, right?
Yeah.
So even if it just is in a local environment of your nose and your throat, and you try to breathe in that hot sauna air, we're built in a way to try to balance that out, right?
Okay.
So we have air in our lungs already that's at a much lower temperature than the sauna. So you breathe in some of that sauna air.
Breathe in the hot air of the sauna, but don't worry, the air that's in the lung is going to cool it down.
It's going to cool it down, right. So obviously if 130 degrees is damaging to the virus, 130 degrees is damaging to our tissue too.
Gotcha,
right?
gotcha.
So 130 degrees would essentially cauterize or burn our own tissues. So,
okay, so probably not. It's not an effective way to get rid of the virus.
So don't stand in front of your blow dryer and try to breathe in all that air. It's not going to help.
Gotcha. Okay, so now the sneezing. So obviously we got to cover our mouths while we're sneezing, but they're talking about, well, if you sneeze, about 10 feet, it's going to go 10 feet and it's going to drop. So just stay 10 feet away from the next person. What do you think?
Most of the larger particles are going to settle.
Okay.
Right. So you sneeze, the particle size are all different sizes, right?
Yeah.
Some big, some small. The smaller the size of the particle, the more it can hang out in the air.
Okay.
It'll take longer for it to fall, and it'll attach to land on some surface. So that's another reason why you want to make sure you're cleaning all the surfaces.
Okay.
If you are coughing and sneezing, wipe everything down to make sure that any of those droplets have been sanitized, disinfected. But the virus in very small particles can survive in the air for a fair period of time.
Gotcha.
And it could, air conditioners and heaters and stuff are also blowing air around, so could easily distribute these very, very tiny particles to a broader range than 10 feet.
Yeah, and so literally, this could hang out in the air in like 2-3 hours. Small little particles hanging around in the air. And so just because someone's sneezing and they've covered their mouth and you're 10 feet away doesn't mean those tiny little particles are just hanging around, okay, right? And you're breathing them in. And so, another thing is like, hey, no worries. Just keep drinking water. Just keep swallowing. Drink warm water, because if the virus gets in your mouth or whatever it is, it's just going to go down into your throat, into your stomach acid, and it's going to kill it.
It will kill it if you swallow it. It gets into your gut, and it gives your gut a chance to sample that and start building an immune response. But it's not going to appreciably change the amount of virus that's being shed. Mm-hmm. So much virus is coming out of your lungs and coming out of your respiratory tissue that you'd have to be continuously drinking water just to keep it flushed.
Gotcha. Okay. And so this is a big topic, okay, right? And so survival of this virus, okay, right? So on plastics, on cardboard, on steel, what they're saying is that, so plastics is about 3 days, steel is about 2 days, cardboard about 24 hours. That's why they're talking about, hey, these Amazon packages and things like that. So what's the truth to that, and what really decides whether a virus is going to live on a surface or not?
Some of it is how porous the material is. A cardboard obviously has some absorptive capacity, so it's going to absorb some of the moisture away. Not going to allow it to sit, viable for very long. Plastic and steel don't have that ability to wick away the fluid, dry it out and desiccate it, basically. So they can sit on those surfaces a lot longer. Chances are, if someone is sick in a room and they deposit some virus onto a plastic or stainless steel, you're going to come along and within a couple days probably touch it, right?
Yes. So
it has been shown that it can stay on surfaces, a variety of different surfaces, for hours to days, right? Which is why it's so important to disinfect your environment. If you are sick, wipe things down. If you're in a room with other people, wipe things down. Wash your hands. Be cognizant and aware of, the virus could be anywhere. So let's be very careful about cleaning and personal hygiene and doing this on a frequent basis.
Gotcha. And so remember, guys, here's the thing. So the virus stays alive because it has hydration. It has water, okay, right? And so here's the deal, is that here I am, I've got my coffee cup, I sneeze in my coffee cup, let's just say, there's a lot of hydration in there. That virus can stay in that coffee cup for days upon days, whether it's a steel cup, whether it's a cardboard cup. I know that's silly, there wouldn't be a cardboard cup, but the whole point is that's why when you wash your hands, one of the most important things is to dry your hands, because if you don't dry your hands, it can literally live on your hands. And so the key thing is that water.
And soap, right?
And soap.
So because of the structure of the virus, it has this fatty envelope around it. The soap does a great job of disrupting that envelope.
It breaks it, right?
It breaks it up, it disassociates it, and the water is more than plenty to wash it off, wash all the debris off, right? So just make sure your hands are clean, wash them frequently, wipe down your counters, wipe down your workspaces if you're, someplace where, you might be with other people. It's always a great thing to keep always cleaning, being very aware of wash my hands.
Exactly. Great. And then the last thing before we figure out what we're actually going to do, how about these masks? Because you got a lot of people, wanting masks, using masks. My sister asked me today, hey, can I go grab some masks? What is
the mask is most helpful if you're sick to protect other people from catching what you have.
Okay.
The idea that if you wear this mask around, it's going to protect you from everybody else has maybe a little bit of protective effect, but by and large, the masks have break points around them, around your nose and on the side. They're not sealed, they're not tight. If you have any facial hair, that creates another avenue for air to get in. Mm-hmm. What you want the mask to be is a protective measure so that if you have to go to the doctor, you don't potentially expose anybody else, right?
Yes, gotcha.
Think about a surgeon, right? The surgeon doesn't put the mask on the patient, the surgeon puts the mask on him. Right? He's protecting himself. He's protecting the patient from anything he might transmit, right?
I see.
So if you're going to use a mask, use the mask to protect everybody else around you. You're already sick, right?
Yes.
And that means that healthcare people need those masks, right?
Yeah.
They need to be able to now in this particular case, they're trying to use that to serve as another barrier, right?
Yeah.
But for those of us who are out in the community, the mask is intended to be a protective mechanism against.
So we don't cause any more trauma to society. You know what I mean? Right. Gotcha.
Right.
Okay. So now that we've talked about, what, Dr. Vigerust, what can we do here? Right? What can we actually do to, to flatten the curve that they say, to protect others, to protect ourselves? I mean, I know one of the things that you've touched on just real quickly is that your lab is going to start testing for COVID-19 in a couple weeks. Testing is obviously really key.
Right. We need to identify who's been exposed. And if a fair portion of the people who are exposed to this virus will not display any symptoms.
Yeah.
So you're not going to know looking at them that they're sick. They're going to look normal and they're going to have probably no effects whatsoever. So if we can identify who's had exposure, because they're not sick doesn't mean they're not transmitting, right? Because this is such a transmissible virus, you can be perfectly healthy appearing and shedding copious amounts of virus to people around you.
Right.
So it's important to get tested, especially if you've been...
Not too early either, right? Because if you get tested too early, would you have a false negative because you don't have enough of the virus?
Right,
is that right?
That's true. So let's say you think you got exposed yesterday afternoon.
Okay.
First thing this morning, you go get tested.
Right.
The chances are the virus hasn't had enough time to reproduce to the place where you can get a good sampling to find out if you have it or not, right? It might take a couple of extra days to get there. Mm-hmm. So testing is important, making sure that if you've had any kind of exposure, if you're not feeling well, you get tested. If you don't feel well, don't go out, don't go to the gym, don't go to the
quarantine and
store.
social distance, right?
Right. Try to keep some space. Try to keep yourself as healthy as you can.
Right.
So if you take vitamins, if you exercise, if you like to get outside in the sun and get a walk, those are all great things to help boost your immune response, right?
Yeah.
You don't have to do it in a crowd, but you can certainly sit at a window and get some sunlight.
Yeah.
You can sit on your porch and get some fresh air and some sunlight. You can still exercise. Trying to keep your immune response as robust as possible is a great idea all the time.
Yeah.
Right?
Yeah.
Especially now, because if
and
your
nutrition is up to you.
Yeah, if your immune system starts to dip, you make yourself a better target for the virus.
Right. And then certain nutrients are always really powerful. I mean, taking a more multidisciplinary approach in looking at the types of nutrients that you're putting in, right?
Right. And that's one of the things that I like about the products that PRōZE has is a number of your products have reishi mushroom and ashwagandha, and those two things have an immense power to increase your immune response. In particular, your white blood cells. Right. And in further particular, the NK cells. And the NK cells in our immune system are responsible for finding viruses.
Natural killer cells, right?
Natural killer cells. Finding viruses and killing them.
Okay.
And they don't care what virus it is, they're just out, they're assassins.
Yeah.
Right? So they're assassins circulating through your system looking for things to wipe out.
Yeah.
So those two products, they increase your white blood cell count, they increase the activity in NK cells. So if you do get exposed, you've got a better immune response to it.
Yeah,
right?
I always...
The other advantage of the ashwagandha is it's an anxiolytic, right? So it helps you with anxiety, helps you to cool out a little bit and not be so panicked.
Yeah.
Relax, it'll be okay.
That's huge right now.
Yeah.
I mean, I always say that stress, guys, stress, and this is why this is so important, what we're doing today, is we want everyone to just calm down. Don't worry, everything's going to be okay, right? You've got a lot of powerful tools that you can use, because here's the thing, your immune system, its underpinnings are stress. And if you are stressed out, your immune system is going to be significantly compromised. And I don't care how much vitamin A, I don't care how much vitamin C, I don't care how much vitamin D, I don't care how much ashwagandha and reishi mushroom, that is not going to overwhelm the fact that you are so stressed. But what it can do is obviously help you kind of through this.
Help to support, right. So sleep is a great way of keeping your immune response up, right? Exercising, sunlight, eating well.
Yeah.
All of those things are going to help to maintain your immune response to its best potential.
Yeah.
Be aware of the kinds of things we've already talked about. Keeping your environment clean, washing your hands, don't touch your face, which is an incredibly difficult thing to try to get used to, is to not touch your face, because we're just so...
Oh yeah, I had like a beard a little bit, and I had to shave it because literally, as much as I knew not to touch my face, I would catch myself like scratching it or whatever it is, right? And so here's the thing, guys, is that, like I said earlier, we all got to do our part. We all got to do things together. One of the things that we want to do at PRōZE real quick is that we know that our products can be incredibly supportive to the immune system. We know that things like sleep is obviously another huge thing, and time in your day in which your body is repairing and rebuilding, and if you're not getting the right sleep, then you're not getting the right recovery. So what we've done with PRōZE is we're doing our part. We're going to have 30% off all of our products, Shield included, and we even have a product set that we term Day and Night, which is the Shield product and the Nods product, which is something you do during the day, and then Nods to help you to get into that deep state of rest and relaxation, to give you that proper sleep and that circadian medicine, as we call it, and we've actually done a special discount on that of 35%. So we're just trying to do our part. We know it's a tough time for all of us, and so having good nutrition, having good nutrients and products is important. And I hope other companies, by the way, follow this lead. I hope other companies that are promoting really great products, vitamin A, vitamin D, quercetin, glutathione, all that sort of stuff, that they're discounting or offering specials during this time, because it's so huge, I think.
Right.
You know what
Yeah,
I mean, right? So here's what we're going to do, guys. Let's get into some questions that we've gotten from the group. And so I know we've got a few, so we're going to get them here from our team. So one of the first ones is, hold on one second.
Okay, we have Sandy asked, can this virus COVID-19 infect our pets?
Okay, can COVID-19 affect our pets?
We've seen very little evidence of that. There was a couple of very small studies out of China early on in this that showed a couple of dogs that lived in the same household as someone who was sick had very, very low levels of COVID-19. And that probably relates back to what I was mentioning about the host needs to be the right host for the virus, and a canine may not be the right host.
Gotcha.
They may have some of that virus in their respiratory tract, but it's probably not able to interact with the host very well. So that means that virus is just going to eventually be flushed from the system and die.
So it looks like, that this virus that started from an animal, because like we talked about, it was in balance with the bat or balance with the animal, that it's not showing any significant symptoms for dogs at the moment. Right. Okay, second question.
Marisol asks, why are kids not being affected by the virus?
This is really good. This is, interesting. Why don't you see any type of symptoms and or...
Very few cases have been found in kids, or actually I should say people younger than 18. That could have something to do with the expression of the receptor. The receptor may not be very abundant in childhood.
The ACE receptor.
The ACE receptor, right. In childhood and adolescence. And there's been a couple of papers in the last couple of weeks that have discussed that we may perhaps be seeing an increase of maybe 1.2-fold every 10 years of life. So as a child, maybe very low levels of ACE2. As an older person, very high levels of ACE2. Chances are, if you're a 10, 12, 13-year-old kid, you probably don't have high blood pressure.
Right.
You're stressed, but you don't have high blood pressure, right? And since this receptor is involved in blood pressure control, that may be a possible explanation. It may be that, the host, a young host, sometimes is just not the right environment for the pathogen. And we see this with a number of other pathogens too, that they do really well in an adult, but they do very poorly in a child, and vice versa.
Ah, interesting. Wow.
Okay, Scott asks, the current advice of social distancing will allow the virus to die out. However, if there is a reservoir of the virus somewhere in the world, don't we face going through the same exercise all over again?
It's possible once we understand where the reservoir is. If we understood that it was bats, or we understood that it was pangolins or chickens or whatever the animal host is, we can certainly squeeze down on that exposure. The social distancing is not necessarily going to eradicate the virus. The point there is to try to straighten or level out the curve a little bit so that not so many patients get sick all at once. If the likelihood is all of us are going to get exposed to this over time. We don't want everybody to get exposed today. We want people to have a longer period of time to get exposure, potentially get immunity to it, potentially have drugs and other things, other supportive cares that can help. The principal reason for doing a lot of this social distancing and those methods is to not overwhelm the healthcare system.
Yes, gotcha, right? Gotcha.
I don't know if we can necessarily put a stop to it, eradicate the virus. We're going to try, obviously, but we need to spread out that time period so that we can handle it in a way that everybody gets the best of care.
So we may it won't be necessarily a conversation of eradication. It's about either the balance of this virus to us. Secondly, the ability for us to create some vaccines or such that would offer some support to those that are having the severe symptoms.
Right.
And then, as they always say, the vast majority of us, the symptoms are very mild. Okay, right? And that's why we're talking about some of the things at the end, what you can do, because we're trying to say it's not the virus, it's the host. How healthy are you? What are you doing for yourself that when something like this occurs, because it's not going to be the last time something is going to infect us that has never been seen before. It's going to be whether you have the strength to defend yourself against this, right? So
Jessica asked, what is the best advice we can give to our healthcare professionals that are on the frontline responders or exposed to repeated viral loads from infected individuals for extended periods of time?
The best advice to give them, they're doing everything they possibly can to create a barrier between them and the patients, right?
Yeah.
Which is, we need to make sure that they get the masks, that they're prioritized for the masks. We need to make sure we have protective equipment for them. We need to make sure that they're supported in every way possible so that they can take care of us when and if we ever do need to go to the hospital. Right.
That's a great point. We need to support these healthcare professionals, because remember what I was saying. At the very end of the day, the underpinnings of immune compromisation is stress. And these guys are stressed out. We got to do everything that we can, love on them, help them, support them, encourage them, not overwhelm them, so that we don't stress them out any more than what they already are, because it's going to only affect their immune system. And now we've got our people that are supposed to be taking care of the rest of us sick as well,
Right.
So make them casseroles and do all that fun stuff and mow their lawn and all that sort of stuff. Yeah.
Okay, Robert asks, if we stopped eating animal meat, would we avoid getting these deadly viruses? Should we all be vegetarian?
Well, these viruses exist everywhere in nature. Some of them do come from meats. Some of them come from fruits. So I'll give you an example. Nipah virus and Hendra virus are viruses that are transmitted by a bat. The bat actually gets onto the fruits. It shares its saliva on the fruit, and then we ingest the fruit, right? So even if you're a fruitarian, or whatever the word is for somebody who just eats fruit, you can still get exposure to these viruses. Even if you're not eating the animal itself, you can still get exposed. And a variety of different vectors carry viruses as well, right? A couple of years ago, we had a problem with Zika. Zika comes from mosquitoes. Doesn't have anything to do with what our diet is.
I'm not eating any mosquitoes,
Right. So, and it's just, we're going to encounter these from nature for a long time to come, and they're going to come from a variety of different sources. Some animal, some plant, some insect, some from the soil, some from everywhere, right? So we can minimize it to a degree. And it's not so much eating the meat that was the problem, perhaps in this case. It was the proximity of a variety of different animals that could serve as a mixing vessel.
Yeah, gotcha.
And that happens around the world. That happens in Africa, it happens in Asia, it happens in South America, where animals may be housed in close proximity, and that allows these viruses to move back and forth.
Okay, Britt and Justin ask, I'm pregnant. Is there more or less risk for immune system? Also, any supplements I could not take?
We're not seeing too much in the way of data for pregnancy in terms of this virus and infection, so we don't know how it may or may not impact that. It's always a bad idea to have, it's always a bad circumstance to have a viral infection during pregnancy, right? Because you never know what the unintended consequence is to the fetus. I don't know if I could necessarily speak to what supplements you could and couldn't take.
Yeah, that's difficult. I mean, with supplements, the reason why we always kind of have the label to consult your healthcare practitioner or provider is because it requires a lot of medical history. It requires a lot of information that we just don't have access to. And especially even the simple things like vitamin A and vitamin C and vitamin D, quercetin and acetylcysteine, probiotics, these are the things that I've been talking a lot about that would help your immune system. But if you are pregnant and or nursing, you always want to check with your healthcare practitioner.
Just to keep in context with any other conditions that may be going on.
Yeah. What I would do is I would eat the whole food sources of this stuff. Okay, right? And so vitamin A, we know vitamin A, retinol is a very powerful active form that's found in meats, right? If you want a vitamin D, have it from eggs and the yolk of eggs. Have a vitamin C from broccoli and oranges and things like that. And so eat nutrient-dense foods and get your nutrition when you're in those types of situations. Not when you're pregnant or nursing, that's not a situation. It just is a state, if you will, right? Just focus on good, healthy, nutrient-dense foods.
Okay, Jessica asks, have there been any mutation of COVID-19 since detection in the U.S., or can we expect the virus to behave the same as observed in China and Italy?
It's quite a bit different. There are a number of phylogeny trees have been developed now, and you can see that there's all kinds of branch points. These viruses, RNA viruses in particular, have a tendency to move, to change, to mutate, to adapt. So we're going to see as they go through people and we have subsequent rounds of replication, the virus is going to have subtle changes. I'm expecting and I'm hoping that what happens is this virus finds the right balance with us, and it finally becomes something that we coexist with without any harmful circumstances.
Because we've done that with other viruses.
Yeah,
is that true?
Okay. Back to the 1918 influenza, it had a tremendously high fatality rate.
Yeah.
We still have H1N1, almost the same variant of it from 1918. It's had subtle changes, and those subtle changes have allowed it to coexist with us better. So it doesn't cause us to have a high mortality.
Severe symptoms.
Right, it doesn't cause us to have a high mortality rate. It causes us to have feverish symptoms, backache, the kind of typical flu symptoms that are almost always non-fatal. For some people, again, flu does kill people every year, or the consequences of flu do kill people every year, and it's mostly people who have underlying conditions, weakened immune responses, other conditions that aggravate that ability to respond and fight the infection.
And that's the beautiful thing about the body. The body wants to live. And one of the ways that it is able to accomplish that is to adapt. So that's what we always have to think about, guys, is that if our bodies are strong, if we're doing the right things for ourselves, if we're taking away stresses and we're adding on building types of nutrients and lifestyles, our bodies will be quicker to adapt and stronger to adapt. And so you always got to be thinking of that sort of stuff.
Okay, final question. Scott asked, anti-inflammatories, ibuprofen, and antihypertensives, ACE inhibitors, appear to exacerbate the severity of the symptoms. Why? What do patients on these meds turn to?
Great question.
There's a lot of debate, especially in the medical community, about the use of antihypertensives like ACE inhibitors and that kind of ARBs. And it's not really clear. You can read one paper today that says don't do this, and the next paper says no, make sure you do this. So the recommendation from the medical community is to continue to take the meds as you've been prescribed. Anti-inflammatories can sometimes dampen your immune response. So if you take an anti-inflammatory, that may turn down your macrophage response. It may turn down your NK cell response. So by taking those drugs, you're damaging, in a way, the response to the virus that you naturally would mount. Antipyretics, Tylenol and ibuprofen for a fever. Fever is a good thing. We have adapted to have fever as a mechanism for making the environment, ourselves, a poor environment for whatever the pathogen is, whether it's virus or bacteria. A little bit of temperature difference can dramatically affect the ability of a virus or bacteria to survive in us. So a little fever is good. A lot of fever, anything above 103, you probably don't want to continue.
Yeah.
But a little fever is not a bad thing.
Cool. Well, awesome. Dr. Vigerust, thank you so much. I hope you guys enjoyed today. We're going to be doing a lot more of this. Like I said earlier, is that whenever we gain some of this knowledge, and obviously PRōZE has put together an incredible panel and board of experts in a lot of different areas, we want to share it with you, okay, right? And we want to share it with you for the number one reason that you are now empowered, and so you can take positive, powerful actions for yourself. And so, Dr. Vigerust, I would, number one, thank you so much for being on this Facebook Live. Thank you, everyone, for sharing your questions. Remember, for the time being, we're going to have 30% off all of our products on our website. We're going to really focus on two particular products, which is our day and night formula to really support the total circadian medicine, if you can, and offer some special discounts on that area. If you guys ever have any questions or anything like that, please let us know, but we will hopefully see all of you here very soon, and please check out emails and such, because we're going to be doing a few more of these educational things.
Thank you, and take care of each other.